Hello and welcome to my video on immunity and vaccines. This is aimed for people studying in the new AQA GCSE biology course. Now a quick look at the things we're going to cover in this video. We're going to look at immunity, which includes barriers to infection and specific immunity. Then we're going to cover vaccines, looking at how they work and a little around the MMR vaccine controversy. The first part of the immune system that pathogens will come across is natural barriers the body has as a defence mechanism. These are usually highly successful in keeping pathogens out of the body. The first one of these barriers is the skin. The skin forms a barrier to the outside environment, and under normal circumstances it stops pathogens entering the body. The only time when you can have pathogens entering through the skin is when you've got cuts or grazes which damage its structure. You've also got stomach acid, which forms another barrier. The stomach acid is hydrochloric acid and it has a very low pH. Under normal circumstances again, it stops bacteria from causing infection. It does this by the low pH denaturing their enzymes and causing damage to the bacterial structure. You also have cilia. These are located within the airways of the body, and they waft to remove any pathogens which have entered the body. You may have heard of cilia with reference to smoking, because one effect of smoking a cigarette is it paralyses your cilia. When this happens, it's double bad news, because not only do you have a load of toxic substances sitting in your airways from the cigarette, but because the cilia are paralysed, you can't actually remove them to the body. Next, you've got mucous membranes. You've got these on all kinds of surfaces, and there's a thick layer of mucus which again stops pathogens from entering the rest of the body. And the final one of these isn't really a barrier at all. I've included it amongst these because it's not part of specific immunity, which we'll look at next. You have phagocytes, which are a type of white blood cell. They're present in virtually every tissue of the body, and they move around engulfing pathogens and digesting them to remove them before they can cause damage. Okay, now to look at specific immunity. Specific immunity is all about antibodies. Antibodies are Y-shaped molecules which your body produces to allow you to fight off pathogens which have beaten the natural barriers and gotten into the body. At the top of the antibody you've got a recognition site. This binds to specific molecules which are found on the outside of pathogens. These are called antigens. Once the antibody is bound to the pathogen, it sticks them together into clumps, slowing them down and also marking them for removal by the phagocytes which come along. In specific immunity, you also have a type of cell called lymphocytes. There's two main types of these. You've got the cells which make the antibody, which float around in the blood. You may hear them called plasma cells. And you've also got memory cells. Memory cells are really useful for helping to respond quickly if you encounter the pathogen again. So we'll look a little bit later at how those are involved in vaccines. Now to finish off on immunity, I'd just like to go through some of the pros and cons of both barriers and specific immunity. So first of all, for barriers, the big advantages to this are that the barriers are permanently in place and they don't require any lag time before they can get going. They're very, very rapid and they're versatile, which means they're able to counter any pathogen regardless of whether your body's encountered it before or not. The big disadvantages of barriers though are they can't adapt to different pathogens. They always respond in exactly the same way, which means that they can be overcome occasionally. And they can also become damaged, which allows the pathogens into the body. So think falling over, getting a cut, getting a scab, or perhaps something happens which means your stomach acid isn't the right pH. Then the pathogen can get in and the barriers can be overcome. With specific immunity, the best thing about this system is it responds in a very specific way to each pathogen. Barriers are like building a wall to keep the enemy out, whereas specific immunity is more like having a sniper rifle and being able to take them out very precisely when you want to. The big disadvantage though with specific immunity is it can be very slow to get going in the first place, especially if you've never encountered the pathogen before. So typically it's a few days up to even a couple of weeks before the body can adequately produce enough lymphocytes and get enough antibody produced to be protected against that disease. Now to move on to vaccines. These rely on producing antibody, so they're part of specific immunity. The aim of a vaccine is always to prime the immune system by introducing antigen. That's usually in the form of dead or inactivated pathogen. The aim of doing that is to get the body's specific immune system to be able to respond to it quickly if you come across the same pathogen again. So the kind of responses we're looking for is after you've been immunised against something, you have high levels of antibody in the blood, which provide protection against the pathogen, and you also have a lot of memory cells, which are specific against that threat. So if you come across it, you can very, very quickly make high levels of antibody to protect yourself. Now to finish off, I'd like to say something about the MMR controversy. If you look at the graph to the left-hand side of the slide, you can see what happened when the MMR vaccine was first introduced. What you have to understand is measles is actually a really nasty disease. Before the vaccine was introduced, there were hundreds of thousands of cases in the United States alone, millions around the world. Lots of people getting very ill with measles, and most of these were babies who didn't have very well developed immune systems, and it caused lots of deaths because they weren't able to combat the virus. So what happened is immediately after the vaccine was licensed, it was given to babies, and very soon after, the level of cases dropped very, very quickly. So the vaccine was highly, highly effective in preventing measles, which was killing lots of people every single year and making hundreds of thousands ill. This all changed in 1998 when somebody called Dr. Andrew Wakefield published a paper which linked the MMR vaccine with autism. What this led to is lots of parents deciding not to give their children the MMR jab. This was primarily due to fear of autism and not wanting their child to be affected by that condition. This had a dramatic effect a few years down the line on a number of people getting measles, and as I've said before, this is a very nasty disease which you really don't want to have, especially if you're a baby. Looking at figures for the United States, from the baseline level of when people were being vaccinated against measles using the MMR jab, there are around 50 to 55 cases of measles every year across the whole of the country. In the first group of children affected by the MMR controversy, the rate of measles increased by around 1200% in a single year, as herd immunity broke down with a too low a proportion of the population vaccinated to protect everybody against the disease. One area where there was particularly low uptake of the MMR vaccine was in the state of Florida. Not surprisingly, there was a huge outbreak of measles in Florida, which led to many children getting ill, and a few unfortunately died of measles during this outbreak. Now, to come back to the study by Dr. Andrew Wakefield, it's always the case within the scientific community that where you make extraordinary claims, you need to provide extraordinary evidence, and other scientists are always going to be looking at your evidence, trying to find whether you're right or to prove that you've made a mistake if they believe you to be wrong. When other scientists in the field looked at Wakefield's research, they found out that actually there wasn't a link between autism and the MMR vaccine, and it was just an artifact in his data. His paper's now been completely discredited, retracted and withdrawn, and has been proved to be wrong. Despite this, the uptake of the MMR vaccine is unfortunately still lower than it was when it was first licensed, leading to hundreds of children getting ill every year and a few unfortunately dying of measles. That's all for today. Thank you very much for watching, and join me again next time.